Hello everyone, welcome to Radiatic. Today we are going to solve some MCQs. So do not just watch the video, pause at every questions and think about the answer yourself and then compare it with the explanations. So let's start with question 1. Which statement best explain why Rutherford reject Thomson's plum pudding model? Option you have option A, alpha particle lost all their energy after passing through gold foils. Option B, most alpha particles were absorbed by the gold foil. Option C, a small fraction of alpha particles underwent large angle scatterings indicating a concentrated positive charge. Option D, electrons were observed to be embedded uniformly throughout the atoms. Which are the correct answers among these options? The correct answer is option C, because Rutherford rejects Thomson's plum pudding model because of very small fractions of alpha particles underwent large angle scattering and a few even bounce back towards the source. If Thomson model, that plum pudding models, had been corrected where the positive charge was uniformly distributed throughout the atoms, alpha particles would give or would have possessed through with only slight deflections. So these unexpected observations prove that almost all the positively charged and nearly all the mass of the atoms are concentrated in a teeny central region that called as nucleus. So remember these fundamental facts of Rutherford gold foil experiment. Number one is that the atom is mostly empty space. Number two, almost all the mass is concentrated in the nucleus. Number three, the nucleus carries the positive charge. So these things help to remember why Rutherford rejects Thomson's plum pudding model. Now move towards question number 2. Which discovery directly disproved Dalton's assumptions the atoms are indivisible? Option you have option A, discovery of neutron, option B, discovery of proton, option C, discovery of electrons, option D, discovery of radioactivity. Among these options, which are correct? For that discovery directly disproved Dalton's assumptions that atoms are indivisible. So the correct answer is option C. Actually, Dalton believes atoms were individuals. However, in 1897, J.J. Thomson discovered the electron using the cathode ray experiment. This was the first direct evidence that atoms contains smaller particles. Therefore, Dalton's assumption that atoms cannot be divided become incorrect. So, to be understand, the electron was the first subatomic particles ever discovered. This discovery marked the beginning of the modern atomic physics. Now, question 3. Which sequence correctly represents the historical development of atomic theory? Option A, Dalton, then Rutherford, then Thomson, then Bohr, then Chadwick. Option B, Democritus, then Dalton, then Thomson, then Rutherford, then Bohr, then Chadwick. Option C, Democritus, then Thomson, then Dalton, then Bohr, then Rutherford, then Chadwick. Option D, Dalton's, then Democritus, then Thomson, then Rutherford, then Chadwick. Which options are correct for represents the historical development of atomic theory. So the correct answer is option B. Actually, each scientist answers questions left unanswered by the previous models. Never memorize the name alone, understands how one discovery leads to the next. So option B is says to be first discovery for that atomic theory, that is Democritus, then Dalton, then Thomson, then Rutherford, then Bohr, then Chadwick. So trick to be remembered in orders. First is that idea, then theory, then discovery of electrons, then nucleus, then cells, then neutrons. Now move towards question number 4. Rutherford's gold foil experiments, a very famous experiment, demonstrated all the following except option A, the atom is mostly empty space. Option B, positive charge is concentrated in a nucleus. Option C, electrons occupy quantized energy level. Option D, most of the atomic mass is concentrated at the center. Which options are correct for the Rutherford gold foils experiment demonstrated all of the following except, that means which are not corrected for Rutherford gold foil experiment. So that option is correct option is option C, that is electron occupy quantized energy levels. It is not demonstrated in Rutherford gold foil experiment. It is demonstrated in Bohr's atomic model. Because of Rutherford experiment demonstrated the atom is mostly empty space. The positive charge is concentrated in the nucleus. Most of the mass is presented in the nucleus. However, it could not explain why electrons do not fall in the nucleus. The concept of quantized energy level was introduced by the Bohr. Question number 5. Mostly contributed to the atomic theory was based primarily on measurement of option A, alpha particle scattering, option B, characteristics X-ray frequencies, option C, cathode ray deflections, option D, beta particle emission. So which are the correct answer? Just pause and think. The correct answer is option B. Mostly actually studied the characteristics X-ray emitted by the different elements. He found that the frequency of these X-rays depends on the nuclear charges. This leads to the discovery that atomic number equals to the number of protons, so that it will be also contributed to identify the elements to the atomic number is equals to the number of protons of that element. Now move towards question number 6. The principles limitations of Rutherford atomic model was its inability to explain. Which are the limitations for the Rutherford atomic model? Was its inability to explain. Option A, that is nuclear charge. Option B, that is existence of protons. Option C, stability of orbiting electrons. Option D, discovery of isotopes. Which are the correct answer? The correct answer is option C, that is stability of orbiting electrons. It is a limitations of Rutherford atomic model. Okay, that was its inability to explain. So that according to classical physics, an accelerating electrons should continuously lose energy and spiral into the nucleus. If this was true, that atom was would be unstable. Since atoms are stable, Rutherford models failed to explain this phenomena. So Bohr solved the phenomena by introducing quantized energy level that we are discussed in previous questions. Question number 7. Why was Bohr's atomic model considered an improvement over Rutherford's model? Option A. It introduced the neutrons. Option B. It explains radioactivity or radioactive decay. Option C. It explains atomic stability using the quantized energy levels. Option D. It discovered atomic number. Which are the correct answer among these? The correct answer is option C, because Bohr proposed the electrons occupy only the certain allowed energy levels. Electrons do not radiate energy while remaining in this stationary state. So radiation is emitted or absorbed only when electrons move between the energy levels, the ground state and exciting state, or that valence band to conduction band. Question number 8. Chadwick inferred the existence of neutron because the emitting radiations from the barium. Option A was positively charged. Option B was negatively charged. Option C had no charge but transferred momentum to protons. Option D was identical to gamma. You can guess very easily because of Chadwick also discovered the neutron, that neutron have no charge. So the correct answer is option C. How it discovered? Then the Chadwick bombarded barium with the alpha particles, the emitted neutrons, neutral radiations, you can say that, struck paraffin wax and knocked out protons. Because the radiations had no charge but transferred significant momentum, Chadwick concluded it consisted of neutral particles having nearly the same mass of protons. These particles were called as neutrons that have no charge. Question number 9. Which statement regarding the modern quantum mechanical models is correct? Option we have. Option A. Electron revolve around the nucleus in fixed circular orbits. Option B. Electron position and momentum can both be known exactly. Option C. Electrons occupy probability distribution called orbitals. Option D. Every electron has identical energy regardless of shell. Which options are correct among these? The correct answer is option C. Electrons occupy probability distributions called orbitals. So that the modern quantum models states electrons are described by wave functions. Their most probable locations are called orbitals. Electrons are not confined to fixed circular path. Now move towards question number 10. Which statement correctly relates the contributions of Rutherford, Bohr, Moseley and Chadwick? Option we have option A. Rutherford established atomic numbers, Bohr discovered neutrons, Moseley discovered protons. Option B. Rutherford discovered nucleus, Bohr explained atomic stability, Moseley established atomic number, Chadwick discovered neutron. Option C. Rutherford discovered electrons, Bohr discovered nucleus, Moseley proposed orbitals, Chadwick explained spectra. Option D. Rutherford discovered protons, Bohr proposed isotopes, Moseley discovered electrons, Chadwick proposed quantum mechanics. Which are the correct? You see, that correct answer is option B. Rutherford discovered the nucleus, Bohr explained stability, Moseley established atomic number, and Chadwick discovered neutrons. So that Rutherford discovered nucleus in 1911, Bohr quantized electrons energy levels or explained atomic stability in 1913. Moseley atomic number based on nuclear or nuclear charges, that is in 1913. Then Chadwick discovered neutron in 1932. This sequence forms the basis of modern atomic model. Question number 11. Which one of the following statement is always correct regarding the identity of an atom? Option A, it is determined by the mass number. Option B, it is determined by the neutron to proton ratio, NP ratio. Option C, it is determined by the atomic number. Option D, it is determined by the total number of nucleons. Which are the correct answer? Pause and think. The correct answer is option C, it is determined by the atomic number, because atom having the same atomic number but different mass number, that is called as isotopes. And remember these things, the atomic number represent the number of protons. So it is never changed for a particular element. However, the number of neutrons can vary, resulting in different mass number. So that it is determined by the atomic number. Now move towards question number 12. Two atoms possesses identical atomic number but different mass number. Which statement is best explain these situations? That situation is, two atoms possesses identical atomic number but different mass number. Option we have option A, they have different proton number. Option B, they contains different electron configuration. Option C, they differ only in neutron number. Option D, they belongs to different elements. Which are the correct answer? The correct answer is option B, they contains different electron configurations. As discussed in previous questions, question number 11, isotopes are atoms having same proton number but different neutron number. Question number 13, which nuclear property is primarily responsible for determining whether an isotope is stable or radioactive? Option we have option A, electron affinity. Option B, nuclear binding energy and neutron to proton ratio. Option C, atomic mass alone. Option D, orbital angular momentum of electrons. Which are the correct answer? The correct answer is option B, nuclear binding energy and neutron to proton ratio. So that radioactivity depends on nuclear stability. Stability depends mainly upon nuclear binding energy and neutron to proton ratio. Heavy nuclei requires more neutrons to overcome proton-proton electrostatic repulsions, and electrons properties have almost no influence on nuclear instability or stability. Now, question number 14. According to Pauli exclusion principles, two electrons occupy the same orbitals must differ in option A, principal quantum number only. Option B, orbital quantum number only. Option C, spin quantum number. Option D, magnetic quantum number. Which are the correct answer? The correct answer is option C, spin quantum number. The Pauli exclusion principle states that no two electrons in a same atoms can have the same set of four quantum numbers. That four quantum number is that azimuthal quantum numbers, these quantum numbers. Okay, so that therefore if two electrons occupy the same orbitals, they must have opposite spins. One electron has a spin plus half, yeah, plus 1 by 2, and other has spin minus 1 by 2. Now move towards question number 15. Which sequence correctly represent the physical quantities that determine an atom's identity, nuclear compositions, and chemical behavior respectively? Option we have A, mass number, neutron number, proton number. B, atomic number, mass number, electron configurations. C, electron configuration, mass number, atomic number. D. Neutron number, atomic number, orbital angular momentum. That electron configuration, that means that SPDF, that is the electron configuration you studied. So that correct answer is option B, atomic number, mass number and electron configuration. That identity is atomic number, compositions, that is mass number, and chemical behavior we are determined by electronic or electron arrangement, that is electronic configurations. This relationship forms the basis of both chemistry and radiation interaction. Now move towards question number 16. The above principle primarily explain option A, why nuclei becomes radioactive. Option B, how electrons occupy orbitals in increasing energy. Option C, why isotopes exist. Option D, why atomic number remain constant. So which are the correct answer? Just pause and think. The correct answer is option B, how electrons occupy orbitals of increasing energy, that is explained by above principle. So that above, that means building up. Electron first occupy, that is in lower energy orbitals, before higher energy orbitals. This minimize the total energy of the atoms. So that correct answer is how electrons occupy the orbitals of increasing energy. It is primarily explained by above principle. Question number 17. Which statement correctly distinguishes isotopes from isobars? Option A, isotope have identical mass number. Option B, isobars possesses identical atomic number. Option C, isotopes possesses identical proton number, whereas isobars possesses identical mass number. Option D, both have identical neutron number. Which are the correct answer? The correct answer is option C. That is isotopes, that means same proton numbers but different neutron numbers. Isobars, that means same mass number but different atomic numbers. So that is in different element in isobars, because of if there is different atomic number, that means different number of protons, that will be, it is not in same element. So that element will be differ in isobars. Now move towards question number 18. Which of the following quantities directly influence the probability of photoelectric interactions in diagnostic energy X-ray or diagnostic X-ray? Option A, mass number only. Option B, atomic number. Option C, neutron number. Option D, nuclear binding energy. Which are the correct answer? The correct answer is option B, atomic number, because photoelectric effect depends strongly upon the atomic number. So that high Z, that means high atomic number materials such as lead, iodines and berylliums absorb diagnostic X-ray much more effectively than low Z materials. This is why iodine and berylliums are commonly used as contrast agent in medical imaging. Question number 19. Hume's rules predict the electrons occupying degenerate orbitals will. Option A, pair immediately to reduce energy. Option B, occupy higher energy orbital first. Option C, occupy separate orbitals with parallel spin before pairing. Option D, violate the Pauli exclusion principle. Which are the correct answer for this question? That correct answer is option C. So that we understand degenerates orbital possesses equal energy. Hume's rule states electron first occupy separate orbitals with parallel spins. Only after orbitals contains one electrons does pairing begins. The minimize electron repulsion. Now move towards question number 20. That is the last question for this session. A neutral atom has 34 electrons and a mass number of 79. Which statement is necessarily true? Option A, it contains 45 neutrons. Option B, it contains 34 neutrons. Option C, it contains 79 protons. Option D, it is radioactive. Which are the correct answer? The correct answer is option A. It contains 45 neutrons. How we got that? It contains 45 neutrons because of, for neutral atom, electron, number of electron is equals to number of protons, so that number of electron is given as 34, so that number of proton is 34 and atomic mass is 79. So we just neutrons, that will be 79 minus 34, that we got 45, so that it contains 45 neutrons. Thank you so much for watching. Keep watching Radiatic for radiation physics.